Hey everybody, your Friendly Math Tutor here with video 6 of our SAT one-sheet breakdown series. The PDF files for both the one-sheet and the examples that I'll go through in this problem are linked below. Please subscribe to our channel, check out our Facebook, Instagram, and TikTok, where we got more videos on SAT, AB, BC, calculus, and hopefully we'll be putting up a lot more math material on there. All right, so let's dive into our one-sheet for today. All right, so the one sheet part of today we're going to dive into today is on formulas. So if you notice, the formula sheet is broken down into two types. We've got given on the reference sheet. That's what we're going to do today, and then good to know formulas that you're going to have to memorize that are not given to you on the reference sheet. So let's start with our given on the reference sheet, and today we'll look at 6 formulas, and we'll do an example of each. We've got area and circumference of the circle, so we'll kind of consider that, I guess, one formula. We've got area of a rectangle, area of a triangle, Pythagorean Theorem, and then both special right triangles formulas. So let's start with circles. And the big thing with circles is going to be sectors, so both length of an arc and the area of a sector. So let's take a look at example 1. In the figure above, AB is an arc of the circle, and with center O, the area of the sector is 96 pi. What is the length of the arc? So the area of the sector is related to the area of a circle. So the area of a sector is going to be, you can see down here, you multiply the formula by theta over 360. So to find the area of the sector, so that's 96 pi, that's going to equal theta over 360. So 60 over 360, that's the fraction of the whole circle that this sector takes up, and then it's pi r squared. So we are looking to solve for the radius here. So this is really 1/6, and you can also see that the pi's will cancel. So we really have 96 equals 1/6 r squared. We can multiply by 6. So let me do that real quick. 96 times 6 is 576 is equal to r squared. Then we can take the square root of that, and that is 24. So that tells us that the radius is 24. So we have a radius of 24. Now what it's asking for is the length of arc AB. So now we're going to look at the circumference. Arc length is a fraction of the circumference, and it's the same fraction, 60 over 360. This time we're looking for the arc length, so maybe I'll call that L. And it's 60 over 360, which we already know reduces to 1/6. So now I have 1/6 times 2 pi times the radius, which we figured out is 24. We could do 2 times 24 is 48, and 48 divided by 6 is 8. So that means the arc length is 8 pi, which is answer choice B. All right, so this little piece down here is not given on the reference sheet. Let me make that clear. What you'll be given is the top part, the area and the circumference. You have to know that in order to find the area of a sector or the length of an arc, you just multiply those formulas by the central angle over 360. All right, let's keep it going here and head back to our reference sheet. And now let's take a look at the area of a rectangle or possibly a square. So for this one, we have 2 squares with integer side lengths, and we are told that the area of this shaded region is 28. Well, this shaded region is the area of the big square minus the area of the little square. The area of the big square is length times width, but we know that they're both b because it's a square, so that's b squared. And then b squared minus the area of the small square is a squared. We know that that's equal to 28. So this one, we have to find the area of square ABCD, so that's really just b squared. And what we have to do is we have to figure out what the difference So we have to figure out the difference of which two squares would give us 28. So what I would do in this one is maybe just think about what the perfect squares are. So I'll just write them out here real quick just to go over them also. So 4, 9, 16, 25, 36, 49, 64, 81, 100. We'll go to 121 and then 144. You definitely should know all of those perfect squares. And since they have integer lengths, we know that two of them being subtracted should be 28. So I believe that is going to be 36 and 64. So 64 minus 36 is 28, which means that the area of the bigger one would be 64 and the area of the smaller one would be 36. And they want the area of square ABCD, which is the bigger one. So the answer is 64. You could solve this by factoring. That one takes a little bit longer, so that's why I just figured just know the perfect squares and then just kind of guess and check your way through to figure out which two are separated by 28. All right, let's keep it moving. So our next one is going to be the area of a triangle. So this one wants the area of triangle WXZ. Well, WXZ is this triangle. So what we have to know is that the base of the triangle is ZW. And actually, it's an obtuse triangle. The height of the triangle is not XZ. It's actually XY. It's the altitude is always perpendicular to the base, but the base has to be extended here because it's an obtuse triangle. So the area of the triangle is 1/2 the base, which I'll leave blank, times the height, which is 6. So we already have the height. Now, in order to find the base, we're going to use the fact that this big triangle, so let me outline that in a different color. This big triangle here is a right triangle, and the sides are 6 blank 10. Well, this is a Pythagorean triple. This is a 3, 4, 5 triangle, but if we double it, it's 6, 8, 10. So that means this is 6, this side would be 8. So if the whole side is 8, then that would mean the piece that we're looking for is 8 minus 2, which is 6. So then the base is actually just 6, and 6 times 6 is 36, divided by 2 is 18. All right, so we use Pythagorean triples here, but more importantly, we have to know that the area of a triangle, the formula they give us, but we have to know that if it's an obtuse triangle, the height is actually going to be outside of the triangle. Okay, so next, we keep going. Now we've got Pythagorean Theorem. So here, I just talked about Pythagorean triples, and there's another video, another part of the one sheet that actually has the Pythagorean triples on it. So that video is actually later in the series, but maybe you've watched them out of order. So here, we use Pythagorean Theorem if it's not a Pythagorean triple. So not a 3, 4, 5, or 5, 12, 13, or there's a couple others. Well, this one is asking us for the length of the hypotenuse, and it's a right triangle, so we're going to use the Pythagorean Theorem. But since we don't know the side lengths, we can't use a Pythagorean triple. We kind of have to use the theorem. So if we look at it as a squared plus b squared equals c squared, if I say a squared is 3x squared, so that's 3x squared squared, plus b squared, which is root x squared, equals c squared, and c squared is what we're looking for. So we have to remember when we square this, we have to square the 3 also. So we get 9x to the 4th. Root x squared is just x, and that equals c squared. And if we want to get c by itself, we're going to square root both sides. So that means c is equal to the square root of 9x squared plus x. Sorry, 9x to the 4th plus x, which is answer choice D. Okay, so now our last topic is on special right triangles. So we're going to go over kind of both of these at the same time in 2 different examples. So if we take a look at this triangle here, we've got this is 5, BD is 10. What's the length of CD? So we're trying to find CD. And we look to this left triangle over here, this triangle on the left. It's a right triangle, but it's on the left. And it's a 45, 45, 90. So that means we're going to look at our 45, 45, 90 triangle, which says that our sides are s and our hypotenuse is s root 2. What we're really concerned with is BC, which is also 5. We don't really care about the hypotenuse because we're trying to make our way over to the other triangle. Now what we notice is they don't give us the angles. I mean, we know it's a right angle here, but we don't know what the angles are, but we do know that they are in ratio 5 to 10, which is x and 2x. So that tells us that we have a 30, 60, 90 without them giving us the angles. So when you see that relationship in a right triangle where the hypotenuse is double the short leg, you know you have a special right triangle. So that means if this side is 5, then this side has to be 5 root 3 because the long leg is x root 3. So the answer is B. That is the length of CD. All right, and then let's take a look at one more for our special right triangles. And again, we have another one with 2 of them. So we have this, again, 45, 45, 90, where they say this is 2. We're trying to make our way over here to DB. And this side is 2, which means the hypotenuse, if we look at our 45, 45, 90, is the side times the square root of 2. So this is 2 square root 2. We're trying to find DB. And if we look at our third, so this is 30 down here. Our 30, 60, 90 is, our sides are x, 2x, and this represents x root 3. So that means 2 root 2 is equal to x root 3. This is how we're going to solve for x. So if I solve for x, I divide each side by root 3. And now I have to simplify this. I can simplify this by rationalizing and multiplying top and bottom by root 3. So this gives us 2, root 2 times root 3 is root 6. And root 3 times root 3 is 3. So 2 root 6 over 3 is x. But that's not what they ask for. They ask for dB, which is 2x. So that means I can double this, and that's just going to give me 4 root 6 over 3, which is answer choice C. All right, so that concludes our reference sheet part 1, which is video 6 here, which is just the top half of what's given on the reference sheet. Our next video, we will dive into the second part of that. So we just went over area and circumference of a circle and how to use that with the arc length and area of a sector. The area of a rectangle, the area of a triangle, using Pythagorean Theorem when it's not a Pythagorean triple, and special right triangles. All right, so again, these are formulas that they give you, but the more familiar you can become with them, the better off you'll be, as opposed to just relying on the fact that they're given on the actual, reference sheet. Okay. All right, that concludes video 6. I hope that was helpful. Check out our other videos on Instagram, TikTok, and Facebook. We post a bunch of videos about SAT, AB, BC, calculus, and a bunch of other math stuff that we're going to continue to put out there. All right, again, hope that was helpful, and have a good one.